We have a few more numerical questions from CFSE portion. The crystal field stabilization energy or CFSE for COCl6 4 minus is 18,000 centimeter inverse. The CFSE for COCl4 2 minus will be. Here we are given two complexes. One is COCl6 4 minus. From the number of ligands, we know that it is an octahedral complex. The other one which we are given is COCl4 2 minus, and this is a tetrahedral complex. The CFSE of COCl6 4 minus is given as 18,000 centimeter inverse. We know this relation, that is, we know that delta T is less than delta O and delta T is equal to 4 by 9 of delta O. So the value which we are given is delta O, that is 18,000 centimeter inverse. Therefore, delta T equals 4 by 9 into 18,000, which is equal to equals 8,000 centimeter inverse. So this 8,000 centimeter inverse is delta T. Now delta T is the CFSE for a tetrahedral complex, COCl 2 minus. That is what we are asked here. Next question, how is the crystal field splitting energy for octahedral, that is complex delta O and delta T related? How is delta O and delta T related? Now please take note that in these cases the central metal atom and the ligands are the same, only there is a difference in their numbers. Here in the octahedral complex you have 6 chloride ions and here you have 4 chloride ions. Central metal atom in both the cases is cobalt. So we can take delta T equal to 4 by 9 of delta O. Now here we have to derive this relation, that is delta T equals 4 by 9 delta O. How is the crystal field splitting energy for octahedral complex delta O and for a tetrahedral complex delta T related? We know that splitting in tetrahedral complex is 2 by 3 of that of the octahedral complex of octahedral complex. Let us take delta O as the splitting energy of an octahedral complex. So for one ligand, how many ligands are there in an octahedral complex? There are 6 ligands, right? So for one ligand splitting in octahedral complex is delta O by 6. Delta O is the splitting energy for the complex. There are 6 ligands and so for one ligand it is delta O by 6. for one ligand splitting in tetrahedral complex. Complex equals 2 by 3 of delta O by 6. 2 by 3 is the, we said that splitting in tetrahedral complex is 2/3 of octahedral complex. So for one ligand splitting in octahedral complex, it is delta O by 6. Therefore, for one ligand in a tetrahedral complex, it is 2 by 3 of delta O by 6, which is equal to 2 into delta O by 18. How many ligands are there in a tetrahedral complex? There are 4 ligands. Therefore, for 4 ligands in the tetrahedral complex, splitting energy equals 4 into 2 delta O by 18. That is equal to 8 by 18 delta O. If we make it smaller, that is equal to 4 by 9 delta O. Therefore, delta T equals 4 by 9 of delta O.